afternoon, good evening, depending upon where you are. Okay, yes. So those who know me, you will know that I have fallen down a blockchain rabbit hole for the last few years, and I keep on trying to tell people they should think about blockchain. So I will try to explain it to you during this. I'm going to assume that probably most of the people here didn't attend GopherCon India, which is where I took this. Basically, I basically reworked something I did in GopherCon India a couple of years ago, but more specifically for the message today. Okay, so what I'm going to try and explain or try and convince you is that blockchain, we've all heard a lot of the hype about blockchain, and we're talking about cryptocurrencies a lot. What I'm going to try and put over is that blockchain can be a very useful part of a normal software toolkit, right? So that's me trying to explain it to you. And right down at the bottom, you see this really cute GopherCon India icon. Okay, so I've been working on the Ethereum blockchain for a while. So I wanted to kind of share with you a little bit about what excites me about the Ethereum blockchain, to try to get some of you to think about either working on a blockchain project or bringing blockchain into your project in very specific areas. And also to let you know that being Go developers kind of puts you in a very special place. Okay, so here we go. I'll introduce me. I will give you my 5-minute introduction to blockchain for those of you who haven't actually come across blockchain before or haven't really jumped into understanding it too much. From there, I will extend that into Ethereum and smart contracts. And we will have a little bit of a look into, or a glimpse of, the Go Ethereum code base. I shall show you very fast, don't look at it in any detail, please, it's horrible code, just how the Go Ethereum helps you develop software to interact with the blockchain in Go. And at the end, we'll go into some of the things Ethereum is used for today, which is a lot more than it was when I first wrote this early 2018. Okay, so let's get started. Me. You're in Singapore. You should know me. I lived in Singapore from 1982 to 2012, which was a long time. And after that, I just nipped over the causeway. So I'm now talking to you from Johor Bahru. I haven't been to Singapore since February, owing to the fact we have the causeway closed. But well. So I started programming in 1968 because I got into trouble a lot at school, and my teacher thought it would keep me out of trouble. It didn't. I've spent years doing instrumentation and machine vision. I sold custom designed equipment to many of the MNCs in Singapore. And then in 2014, I started work on blockchain and worked with a few companies on it. And now I'm pretty much a blockchain consultant most of the time. So, blockchain in 5 minutes. Here we go. What is a blockchain? It's a load of signed transactions put into signed blocks, which are added into a chain, in other words, a linked list, by signed links, which is distributed all over a decentralized, I'm reading this, it's terrible, it's put all over a decentralized network in a manner so that everybody on the network agrees that there's only one version of it. And they call that consensus. There, done. Yeah, except you've probably got some questions. So, what's a transaction? It's anything that can change the value, the state of something. A transfer of value or data. So, for example, from Dave to Alice, you know, I want to send Alice some money, you know, and send her a message with it, happy birthday. And if this was being done through a website, you could just have a link like this. You know, the parameters to it would be from Dave to Alice, amount equals 100, and so on. And assuming that you start with a blank slate, the current state of your system will be the sum of the effect of all the previous transactions. Right? So obviously I couldn't send the transaction if I didn't have any money. Okay, but I didn't mention transactions, I mentioned signed transactions. So to try and demonstrate this, I'm going to go with a quote from John von Neumann, which you can read. But if we get to the next slide, I have a problem. I think my back end may not be working terribly well. Let's try it again. What I should have here, which obviously was working until I tried to demonstrate it, is an illustration that if I take that quote that you saw on the previous page, change one full stop to a comma, the number that resulted from it will change dramatically, right? And I'm doing this to try and explain because I taught, instead of transactions, we said signed transactions. So you've all come across, I'm sure, hash functions. You use hash functions to obscure passwords, for example. And the reason you use them is a small change in the data causes a large change in the output. So if you take your transaction and you hash it, the hash verifies that nobody changed the transaction. Except, of course, that if I wanted to forge the data, I would also give you an updated hash. So that doesn't help. So what we now do is we encrypt the hash value using public key encryption, which will then prove that the transaction came from me. And let's proceed. So, encryption. You create a truly random private key, right? A private key is a random number. You get a public key and then an address which you derive from the private key. If I encrypt the data and I give you both the data and the encrypted data, you can derive from that my address, which is public information. Therefore, you know that I signed the transaction. So now I would send, do it from Dave to Alice, 100, message, and then I add a signature to it, which is the encrypted hash of the rest of the message. And you can have a look at this. And from this and this together, you can derive the fact that it really did come from me. And I produced this really crazy picture of it, which is partially accurate. There are all kinds of things you can do with this. So I encrypt it to give me a signature. I can decrypt it with my public key and get the hash back, and I can compare it, or I can recover from the data and the signature my address. Right? So the signature is a proof that the data is authentic, that it has not been modified. Right, so now we have a load of signed transactions. and we stick them into blocks. Now, a block is very simply like one page of a ledger. It is a whole load of signed transactions accumulated together in order. There is a sequence to them, just like there is on a ledger. So you have a link to the previous block, and you put a signature for the block at the end. So now, with the link to the previous block, everybody knows that this follows on from there. And with this block signature, therefore, you are guaranteeing that the whole thing is unchanged, it's invalid. Sorry, that it is valid, idiot. Okay, and you do this in a manner that everyone's agreed, and I am not going to go into much of the details on this, except because there are different ways of doing it, but the design of the consensus algorithm should insist that no one no collusion of people can affect the state of the blockchain, that everybody agrees on everything except for maybe the most recent history, and whatever hasn't been agreed on will get agreed on very fast, right? So that we can we can guarantee that everything over 15 minutes ago will never ever get changed, because it would take someone too much work to fake it and get everybody else to agree. Now, what that would mean is that you and I, if we both have nodes, we have an identical copy of the state of the blockchain. There. And for Ethereum, you can have a look at Etherscan, which will show you that it has a whole load of blocks, and it shows you the latest transactions. You can see a list of all the transactions in a particular block. Etherscan is effectively the Google of the Ethereum blockchain. Right, and that's it. That's my blockchain in 5 minutes. I'm sure it didn't take me 5 minutes. It took me a bit longer. It always takes me longer because time is an illusion. Okay, so now what makes Ethereum special? Because I'm sure the moment blockchain is mentioned, the first thing that comes to everybody's mind is Bitcoin. And Bitcoin operates pretty much exactly as I have explained so far. It has like a coin which you can transfer. You can send 1 Bitcoin, you can send half a Bitcoin, you can send a 1,000th of a Bitcoin if you want. But that is all Bitcoin does. It transfers Bitcoin from one address to another. Ethereum is slightly different because Ethereum was founded on a totally a novel principle, which are smart contracts. So, do you remember the data field in that transaction? Right. I mean, I'm sure you remember I was incredibly generous. I sent Alice $100 or 100 somethings, hopefully not rupiah. But I also had a message. I said, happy birthday, buy yourself something nice. Now that's a load of bytes. So let's get into this. No, let's go back to there. Sorry. Okay, so we got the data field, and the data field can be interpreted. The first attempts to do anything was just to hook those bytes of data and interpret them as instructions to do something. But Ethereum went beyond that. Ethereum took the concept of not only can we just send information with one transaction, sometimes you can take this information and you can hang it on the blockchain, right? So I could take my code and I could leave it there for other people to interact with, right? Now, in order to do this, we need a way to give my blocks of bytecode an address. So I send my transaction in a specific way. I've got a horrible feeling I explained this a bit later on, but I always get ahead of myself. We have compilers that create bytecodes. We have virtual machines. So at the heart of Ethereum, you have a virtual machine built into the Ethereum client, which will interpret those bytecodes. It will take some of that bytecode and leave it there as transactions. And sometimes it will take that bytecode and treat it as an interaction with a contract. And this is running on thousands of nodes across the ecosystem. And I will try and catch up with that in a moment, right? So a smart contract, it is a load of data hung on a particular address. You send your data in a specific format, right? So we start off obviously with a source code, which is something vaguely like JavaScript or vaguely like Python. There are two major languages. There's one called Viper, which is obviously the Python-like language. And there is Solidity, which is a JavaScript-like language, right? You compile that code into a bytecode, and if you take that bytecode, you can then deploy that and you get back an address, right? So your contract ends up on the blockchain and it can be interacted with it. And you can interact with that contract because that contract now has an address. You can send a transaction. Instead of me sending it to Alice, I can send it to an address on the blockchain. And if you look at this carefully, it tells you, it says up here, okay, there is a function name, swap exact ETH 4 tokens, and that has parameters. And from the 0x down to the end here, that is the bytes that I sent. The first 4 bytes operate the function routing. So that determines that I'm actually going to call this function. And everything else in here are the parameters encoded in such a way that the contract I'm talking to will not only execute that function, but it will do it with this data. Right, now, this is me talking to the blockchain. Now, when I talk to the blockchain, I have to push my transaction onto the blockchain, and it has to get included into a block and agreed by everybody else, and that can take some time. Reading back from the contract can happen a lot faster. And the first way is to call a read-only function. Okay. If I call a read-only function in the contract, I do not need to interact with the entirety of the blockchain. I only have to interact with my local node, the one point with which I'm connecting to the blockchain, which could be a Raspberry Pi sitting on my desk. Right? So I can interact with there, and I can find out what the state of the contract is. The other way would be that when my transaction has been completed, the contract itself can log data, and so it uses events and it puts data back into the log, which ends up inside the transaction when it has been mined. And Ethereum uses something called Bloom filters that will allow you to do very fast searches for events that have been emitted by a contract. So we can read back So we can push data to a contract, we can make things happen, we can get information back. So why is this important? Well, a lot of things are now happening with blockchain. Blockchain is starting to move into the enterprise, and it's moving. One of the places it's moving is basically in making people more accountable. Because one of the principal advantages of the blockchain is that it is immutable and it is transparent. So you can see every transaction. Now, yeah, when I talk to my bank, I log into their back end. I have to assume not only do they remember everything that I did. So if I log in and do a transaction, I have to assume that they are not only going to keep that information properly, but also that every single transaction is being executed correctly. There is no way that I can check. Or I can check in a black box format. I can do what I did in the early 90s. I can look at my bank statement. I can see my housing loan, the interest they're taking for my housing loan. And if it doesn't seem to add up to me, I can then do what I did in the 90s. I went to Hong Kong Shanghai Bank and I said, you are calculating my housing loan wrongly. And that is a really painful thing. It took them months to actually agree. I mean, the bank manager couldn't calculate housing loan interest. It was scary. But it took them months to agree that their calculations were wrong. I mean, finally they did, but it was a very uphill thing. If more information is transparent, you can see how everything is working. But even if you have proprietary systems, we've got my ERP system talking to your ERP system. If something goes wrong in the interface between my system and your system, we then have a problem figuring out whose system has got a problem. Did you send the transaction? Did you not send the transaction? Did I fail to acknowledge something I had received? Or did I not actually receive it? So, this thing about making sure that these things work properly can be a little bit of a problem. And if you have a trusted third party, how can you make sure your trusted third party is indeed trustable? So one of the benefits that your blockchain can bring is that we can have, if I look at what I drew, we can have two proprietary systems talking through middleware to a smart contract, right? I would have my keys operating my side talking to the blockchain. You'd have your keys, and we can have a backwards and forwards conversation where particular items of that conversation are being logged. And once we do that, you cannot dispute the things which have been logged by this. So now we have a record which is transparent, it's permanent. There are options using enterprise blockchains like Quorum, which is effectively Ethereum with a few privacy steroids. But the information that would be logged by the contract could actually be used as some kind of point of truth or point of evidence in terms of any disputes. Okay, so yay, there we go. This is, I mean, there's a lot more to using blockchain. We know, for example, that JP Morgan are now using blockchain as an international settlement layer for them talking to other banks. We know, for example, that there are several things out there in the real world for tracking artworks and other valuable items on the blockchain. We know that UPS, for example, trialed using blockchain for tracking and managing their delivery services. So there are a lot of people out there using or investigating where they can use blockchain. So let's see what happens now for Go. As Go programmers, because we are a Go meetup, and those who know me know that Go is one of my preferred languages. So the most important thing is that the reference implementation of the Ethereum client is written in Go. Not only is it written in Go, it is incredibly well written. Right? There's a very nice guy, Peter Suragi, in Romania, who is basically leading the project, and he and the other developers have done a fantastic job, not only to build a client, but if you are writing in Go, you can link right into the code base to do a lot of the things you need to do. So it's very easy to code transactions, and it results in a framework that would allow you to build code to interact with the blockchain very easily. And I have been using this now for the last 4 years to do all kinds of things. Right? And sorry, yeah, just there. So yes, it's Ethereum / Go Ethereum on GitHub. Right? Not only is it written in Go, it is so amazingly well written. It is. In 2014, I had to work on a different code base. It was called Ripple. It was written in C++. And I seriously could not find my way around that code base. It was absolutely horrible. The moment I saw the Go Ethereum code base, it was like reading poetry compared to the Ripple code base. Okay. So yes, it is really nice. It is being well maintained all the time. Now, I'm sure you can't read this too well, and to be honest, we're not doing a deep dive, so I don't expect you to try and read too much of this. But there are a whole load of tools to allow you to play with writing smart contracts, to prototype smart contracts. These tools are all evolving. Sadly, a lot of them rely upon JavaScript and Node, which breaks my heart. But I build my own in Go, so I'm happy. But this contract is kind of like JavaScript, but it's got blockchain specific things in here. So, like I said, if the de facto client is written in Go, you can interact with the logs in a very low way. And one of the things that has been created is ABI Gen. ABI is the application binary interface. ABI Gen will put a wrapper around your contract. So if you want to read through the logs, it's very simple. You can create a while loop. You create an object that will just read the events, and you just create a while loop reading the events as they come in. Or you can create a stream to read those events. So you can read past events. This is pretty much what would be involved, just to read through every single event in the past. And I had to use something like this to analyze when a particular token had a problem and I had to migrate it to a new token. So I just pulled out all the past events off the blockchain. Oh, by the way, if you have questions, please post your questions, and we can come to them towards the end. Right. You can read the contract status equally easily. Right. It just becomes a function call using the wrapper. And you can send transactions equally easily. Right. All you need to do is you have your private key. You need to make sure that that private key has enough funds to pay for the transactions, which is not much. And you know, everything is, you know, I mean, like this amount of code is enough to interact with a contract. Now for testing, now I did mention most of the tools are written in JavaScript, but thank heavens the people who built the Go client also built a simulated blockchain so that you can test out your contracts by deploying them on your simulated blockchain, and you can basically hammer these with basically the same kind of thing, test-driven development. And there is one project, Chainlink. They build oracles. They're also hiring Go programmers, and their entire test suite is all written in Go. Right. So the great thing about the simulated backend is you know that everything's going to be handled correctly because it uses exactly the same Ethereum virtual machine that the Go Ethereum client does. Okay, so there is definitely a niche for Go programmers in the Ethereum space. That's my first take. So if you're a Go programmer and you're looking for a new opportunity, that you can, for example, check out Crypto Jobs List, and you will find people like Chainlink are hiring Go programmers, and most people in the blockchain space are working remote. If you are incredibly good at blockchain, of course there are other blockchains out there also hiring Go programmers. As a Go programmer, you will have a tool set that will put you in a slightly different place from the other programmers. There are a lot of people jumping into writing smart contracts. Right? When I started writing smart contracts in 2015, 2016, you know, there weren't very many of us, and that was a good opportunity. But pretty soon, obviously, where there's a good opportunity, a lot of people follow. And now there are a lot of people writing smart contracts, but there are not so many people writing Go code to interact with the blockchain. Right? So yes, you will have a tool set which is unmatched by the main group of programmers. And you will find it incredibly interesting. Also, however, if you are still building enterprise software, it is worth looking at using Ethereum smart contracts for particular places where you need public records, where you need traceability, where you need accountability in operations between two people. Right. I think that was kind of it. Right. Let me see. I have some questions here. Let's look at the questions. Proof of work is horrible. Yes, proof of work is horrible. Proof of work, the method by which the Ethereum blockchain works is by lots of people doing an awful lot of work, wasting a lot of energy, and that is used to kind of be your stake in making sure that nobody can hack the blockchain, take it over. If Ethereum 2, which is a proof of stake blockchain, which does not waste as much energy, is launching on the 1st of December. And it's going to be a very careful introduction, because this is the ultimate in testing in production. So they're actually going to be there's actually going to be a migration from the current Ethereum blockchain to Ethereum 2 over the next few years, to try and get more off of proof of work. Benefits of blockchain outweighs mainstream methods. The answer to that is I don't know. And this is why I say that, you see, when it comes to writing software, I'm very pragmatic. I use the best thing for the best, whatever seems appropriate at the time. There are times, as I say, there are times when blockchain can be very useful. There are also thousands of times when using blockchain would be a really bad idea. People said, over the American election, people were saying it should be on the blockchain. Then you couldn't argue about false results. But there again, if you talk to the best researchers in the business, they say using blockchain is a really bad idea for a whole load of reasons that they can give you. So no, I wouldn't. So it's really a matter of horses for courses. It's just like, when would you use Postgres versus MongoDB? Well, you use what seems right at the time. It's a matter of building your design. In terms of maintenance is concerned, hey, the great thing is you don't have to maintain the Ethereum network, right? You don't have to have a server on all the time if you've got things on the Ethereum code base. You don't have anything in the cloud at all, right? My ERP system running on a machine in my office can talk to your ERP system sitting on a machine in your office. All you're paying is the transaction cost to put your transaction on the blockchain. But there's a lot of trade-offs, and you're going to have to do your own research on this. I'm just putting ideas in your head, right? This is one of my bad habits. If you want to read logs in a blockchain that's several thousand blocks deep, how do you go to that particular block efficiently? The answer is you don't. It's very unlikely that you want to see all of the logs in one block. If you were to do that, yeah, you go to Etherscan, and they basically index the blockchain, stick it in a database for fast dicing and searching in different ways. But what you normally want to do is you want to see what a particular contract has done. Now, if you want to do that, you'll you'll basically filter the logs, and that uses the Bloom filters, so that the Bloom filter is it can give false positives. It will not give false negatives. So if you're looking for a particular kind of log, you can go through block by block. You don't have to look at the individual transactions. In the block, there is a Bloom filter which will tell you whether it is worth looking in that block to try to find the transactions. Right? So basically that there's an index for logs associated with the blockchain. Right? And you literally just ask your client, you say, filter the logs, find me transactions for a particular contract, this type of transaction, possibly this kind of transaction with these index parameters, right? And all of that is indexed in the Bloom filters. And if you want to be faster, you can give it a starting block. So obviously, if it's a contract that's only been on the chain for the last 6 months, you'd start 6 months ago. You wouldn't trawl through the entire blockchain. Yes, Ambrose, Go Ethereum is fantastic code. Really. And I have about 10 lines of code in there. Nothing critical, but I have 10 lines of code in there. That is like one of my little ha moments, right? Proof of work is not a bug, it's a feature. Well, it has its advantages and it has its disadvantages. But the biggest problem with it is the fact that it uses so much power, and also it slows down the blockchain. Right? Okay, now we've probably got a lot of people who are thinking, what the hell are we talking about? Proof of work. Everything in terms of building the blockchain is based on incentives. So in proof of work, you have a lot of people competing to produce the next work, the next block. So I want to send out a transaction. I throw it out into the transaction pool. I publish it to the transaction pool. And people who are called miners are now trying to build up the next block. In order that it's not just the person with the fastest computer can create the next block, there's a little contest built in, which goes like this. You build a block, and that block has to pass certain mathematical tests. And you can again, it's all based on hashing. So basically, your block hash has to meet certain criteria. And the block hash will depend on the order of the transactions, which transactions are in there, and so on. And the person who wins that, the person who meets those criteria first, gets to append the next block. And then people will take the existing chain with that block and try and add another block, and so on. And in the end, the longest chains win out, because if I will produce one with another block and that becomes a contender, someone else may do it at the same time, or not necessarily quite the same time, because of course things are everyone's everywhere, right? So by the time one contender will be a few blocks longer than the other one, that contender wins, because everybody will say, hey, this is the longest one, we'll go with this. Right? So proof of work puts in the delays because it's not just pure computing power, it's also kind of a chance, depending upon how I put my blocks together, whether I can get there first. Right? So proof of work gives the kind of randomness so that it's not just one person in control of the blockchain. The downside of it is that meeting the criteria is difficult. It has to be difficult to kind of level the playing field. Difficult mathematically, which means there are computers out there with massive GPUs, all trying to win that prize. And because they've all got massive GPUs, they're burning up a hell of a lot of power. And so we're trying to, by moving away from proof of work, you are trying to reduce the amount of power being burnt. All right, I'm looking at the last one. If you implement in production, how do you send the information efficiently to your data warehouse to use? So what you would do, if you look at it, basically look at Etherscan. Etherscan, as I said, it reads the blockchain events as they come in, but it stores them in a database. Okay? The important thing is that you should be able to verify everything. So you got a data warehouse, do what you always do, bring the information off the blockchain, chuck it into your data warehouse, and analyze it from there. But by having the transaction hashes, you can always go back to the blockchain and verify that everything in the data warehouse is correct. Right? So for the drill down, at the lowest level of the drill down, you can get back to looking at the blockchain.